Am I audible?
Yes, sir.
Yes, sir.
Okay. Thank you. Sorry, I got confused with the lecture at 11:45. I thought my lecture was at 11:45 and I could not take the regular lecture. So we were talking about one topic in the last lecture, that is the key generation problem. So we have talked about the case where there are 4 users in a organization, A, B, C, D, and if they want to communicate with each other, they will have to, create the keys at their end, right, for each other user, right? And if these number of users are, getting increased, it will have more number of keys. Like the keys we are talking about here is n squared, right? So this is quite a huge problem for the employees which are having, either if you have 1,000 employees or 50,000 employees or so. As you increase the number of users, this kind of logic doesn't work. So each will have these many keys, and this system administrator have to install all these keys. So this problem we have discussed, and we also discussed there is a problem of the solution of this problem is KDC. Does anyone have looked at this term? Anyone, please? Anyone have looked at like what could be this KDC? Okay.
No question.
Yeah, sorry.
So no idea about KDC.
No idea. Okay. It's a simple thing. It's a key distribution center. Okay. So why do we need this, and how does it solve this problem? So n square, when these are the n number of users we are talking about, and the number of keys we are talking about around n square. So you think of 50,000 square keys that you have to handle. Okay, so to solve this problem, we will have the solution. Now, what is this solution? Let me just give you the idea. Let's say there are 2 users, Alice and Bob. Okay. Now, what these guys do is they will have their own keys with them. Okay. Let's say KA and KB. Now, they will not store the other users' key. Okay. Here, what in the previous case, what they have done is every user will have to store the keys of all other users, right? So we'll reduce this issue here. They will store only their keys. Either it can be private, it can be a public key and all. So, and there is a KDC involved in this. This is a central authority. Okay, it's a trusted authority, TA, or trusted third party, TTP. You can call it as anything. Okay, so it's a central authority, okay, which is helping these guys to communicate. How this KDC helps these guys to communicate is that KDC will store both the keys, KA and KB. Okay. Now, whenever Alice wants to communicate with Bob, this KDC will provide this key to Alice. Okay. How it will provide? There is a trick Okay, let me give you that trick here. So basically what you have to do is you have to find out a secure channel between every user. Okay, let me make it as a channel. So using this secure channel, if you put the key into this secure channel, it will be not accessible to anyone, and automatically it will be available to this guy, or sorry, Alice. So let us have, okay. So whenever Alice comes into the network, she will share the her key with KDC. When Bob comes into the network, Bob shares his own key, okay, to the KDC. Now, let's say she wants to communicate with Bob at some moment. What she will do is she will initiate a message which will have the ID of herself and ID of the person who she wants to talk. Let's say right now she wants to talk to Bob. Okay, so what she will do, she will send both the identifiers to KDC. Okay, now once KDC receives these two, KDC will come to know that this one wants to talk to this one. So that means his key, the receiver's key, has to be shared with the sender's key, right? So what she will do, what KDC will do, it will generate one key which is called as KSES. Okay, it is a session key, because you will have to whenever Alice wants to talk to Bob, and whenever they are talking, there has to be a session maintained or created for that communication, and for that session this key will be used. Okay, so KDC will generate a new key which is called as KSES. Okay, now this has to be shared with both of them. Okay, now how it will be shared, it's a thing. What KDC will do, it will encrypt this cases. Okay, it will use some algorithm, AES, DES, any algorithm, and it will do the encryption on K session key. Okay, but it will use KA, and it will also use KB. So what KDC is doing, it is encrypting the case session key using both the keys, both the private keys. Okay, so you are getting different encrypted values. Let us call this as YA and this as YB. Okay, any doubt here? See, KDC has both the keys, KA and KB. KDC is using these keys and encrypting the newly generated session key and creating YA and YB. These are the encrypted values of cases. Okay. Now what does this KDC do? It will send these values back to Alice. So YA and YB are sent back to Alice. Now what Alice can do with these two values? Can she decrypt YA? Or YB?
She can decrypt YA using her key.
Using her key, right? So she has, I'm sorry. So let's pull out this. Right. So she can only decrypt YA, but she can't do anything with YB because she doesn't have KB. Right. KB is only with Bob. What she does is she will decrypt YA. So for decrypting YA, what she has to do is the inverse on YA using KA. Okay. What you are getting? Cases. Okay. Now using this cases, okay, you are only getting session key right now. Okay, you haven't done any encryption on your message. So she wants to communicate with Bob, so she has to send some message. So let us say that X is that message. Okay, now you're encrypting this message using cases. Okay, and producing Y. This is a ciphertext of original message X. Okay, now what she does is she sends a message to Bob. Now let's say I'm repeating Bob on the new page, and this is Alice. Okay, so what she does is she sends Y and YB to Bob. Okay, now what Bob does here is whenever it reads this message, he knows that this is a session key and this is the original message. Okay, so what he does, he decrypts YB, that is E inverse, using his own key. Okay, so he knows KB, so he uses KB and decrypts YB. What he will get? Cases, because cases was decrypted using KB to produce YB. So whenever you are decrypting YB, you will get cases. And what you have to do with these cases, you have to use it for decrypting actual message. So again, the same procedure, you will have to use decryption on Y using K session key to produce original message X. Okay, so ultimately what these guys are doing, let me just get the complete picture. Right, so what these guys are doing, Alice and Bob, they are registering their keys with the central authority, okay, key distribution center. Once they have shared their own keys using the secure channel, okay, they don't have to share these keys anywhere. Okay, and whenever they are communicating, they are using the third key, that is cases, which is generated by KDC. Okay, and this is how they will communicate. Any doubts here, guys? Now this is just a concept. Okay, KDC is just a concept. It has to be converted into a protocol. Protocol means what? Whenever Bob receives this kind of message, he has to know that this part is a key, should have a session key, and this is an encrypted original message. Once you tell all the employees or users that this is how we are operating. Okay, so in that case, you can every user will come to know that how to operate on these messages, right? So this is how this concept can be converted into protocol. One of the protocol which is using KDC is Kerberos. I hope many of you have might have heard about this Kerberos. We'll learn about this Kerberos very soon now. but this is the concept which will be used in Keplers. I'm expecting one doubt. I'm giving you 1 minute for that. No doubts?
Sir, this key will be only valid for the current session, right?
Yeah, it only valid for the some time, and during that time you have to finish the communication.
So for the next session, Alice and Bob will have to share their keys again with KDC?
No. See, this case session is generated whenever you send a message to KDC that you want to talk to someone.
Okay.
Then you have to use this key for that particular communication. Once the communication is over, cases is discarded.
Okay, sir,
Whenever, let's
understood.
say after one hour, you still want to talk to Bob, you have to initiate another message, new case session key will be created. These KA and KB are still there with KDC, the old actual private keys.
Okay. Okay, sir.
Okay, no one is asking me why you are sending YB back to Alice. What are you doing? What she is doing with YB? Nothing. You are getting the YB from, like Alice is getting the YB from KDC, and you are sending it as it is to Bob, right? Why you are not sending, like why KDC doesn't send back to Bob directly instead of this communication? So YB is sent over Bob, and why only Y is sent by this guy, Alice. You got my point? Any thought on this? Okay, there are a couple of points. This can be a protocol. Okay, this can be one of the protocols that you send YB to Bob and YA to Alice. This way, Bob will come to know that someone wants to communicate with him. He has to be in listening mode. That is one positive thing. And Bob will be waiting for actual Y. Okay, but let us say that Alice wants to communicate with Bob. Then someone else also wants to communicate with Bob at the same time, and that person also initiates this request at the same time. So Bob will be receiving two YBs, YB from Alice and YB from someone else. So in that case, after receiving two YBs, he will be expecting two messages from two different users. Then he will be getting confused with which one to use for which message. Again, you will have to modify this protocol so that you can add this identifier along with the YB, so that Bob will come to know that who is talking, who is sending the message, actual message. So little bit modification here and there. You have to modify this concept for creating a protocol. Second thing, a KDC will have to talk separately with other users. So it is adding one more, what you can say, redundancy of creating a message for the KDC. because KDC is not helping only these two guys, but KDC might help these 50,000 users, right? So that is one case. You can use both way protocol. Okay, you can send YB also to Bob or Alice this way. These are the two versions of the protocol, but you have to think of what kind of number of users you have and how this will help you or how this will create the problems for you. Now, can we let us say there is one more user in the system, Charlie. Okay, so what will happen in this case? So yesterday when we talked, sorry, last time when we talked about adding the new user to the system, okay, what you have to do is you have to go to each machine and add keys for the new user to each machine or to each user, and you have to update ease record with all other keys also. Okay, so this was the problem faced in the previous thing. So let us consider a new user is adding to the communication. What you have to do is create a secure channel here with KDC and share the KC with the central authority, and that's it. He is good to talk with anyone because there is a protocol history, there is a protocol which you have to install here, and that's it. He will be a part of the network. You don't have to do anything. So one problem is, what are the number of keys we are talking about in this case, right? The number of keys, can someone tell me what are the number of keys we are talking here? It will be n minus 1 or almost n, sorry, not n minus 1. Number of keys that KDC has to handle is the number of users, right? They are not, they are just creating the keys and keeping with themselves. That's it. And you have to register your key with KDC. Now KDC has to handle the number of keys as many as number of users. So we are talking about only n keys in the system instead of n squared, which is quite a good optimization, right? Now, second problem was adding a user was creating many issues, right? The adding the keys to all the users and all these things. That is solved now. Once the new user is getting added into the organization or system, only one key you have to handle. That's it with the KDC, and you are good to go, right? So both the problems are solved with the KDC. Now we'll see the use of KDC in the Kerberos. Okay, sometime later. Now, whatever the key distribution we have seen here, that is the concept that we have seen. Okay. There are two things. One is the private key, and another one is the public key. So sharing a private key is one of the greatest issue with someone else. Because let's say we have to share, like Alice has to share her private key with KDC, okay, using some secure channel, but you have to trust this secure channel, which is another big issue. Okay, how do you trust a channel? Now instead of sharing the key itself directly, what you can do is you can use the public key cryptography for sharing a private key. Okay, Now let us see how you can do that. Have you heard of DC Helman guy? Anyone? What are the algorithms do you know about DC Helman? No? Okay. We'll see the key sharing concept, Diffie-Hellman key exchange. Okay. What you have to do is, let's say both of us, we are talking together. Okay. There has to be one system. Okay. That should, generate the private keys at each of our end automatically. Okay, we are not sending any private key to each other, but there has to be some system. Automatically, I should be able to generate your private key, and you should be able to generate my private key for the encryption. If we are using a symmetric key, symmetric key cryptography, because as we have discussed in Unit 1, AES is the most powerful encryption technique, but sharing the private key is the most difficult issue. Okay, so this guy helps doing that. Okay, how to do that? I'll give you the idea. Again, we'll bring the Alice and Bob into picture. Okay, now what they do is they share few public parameters. Okay, what are those public parameters? There are two public parameters, P and alpha. Okay, if you remember, we have talked about in the last unit, we have talked about some mathematical term which is called as primitive root. Do you remember that primitive root? So P and alpha are alpha is the primitive root of P. I'll come to that again. I'll revisit that primitive root again while solving the example. Okay. As of now, these are the two parameters which we are talking about. They know, like Alice and Bob know about two parameters. Okay. Now, what they do, Alice and Bob, they have their own private keys. Let us call the small a and small b are their own private keys. Okay. What they do is they take this alpha. Okay, because these are the public parameters. They take this alpha. Alice takes this alpha, raise it to its own private key, take the mod operation on P. Okay. And Bob also does the same thing. Bob take the alpha, raise it to its own private key, and take the mod operation. If you have any doubts, please let me know. Now these private keys are chosen by these two users from a set of 1, 2, 3 till P minus 1. Okay, from the same set. It belongs to this set. Okay, so we are choosing the private key from this set. Okay, and we are generating some value. Okay, we will call this value as capital A and capital B. Okay, and we will call this complete or call this as K public of A, and this will be K public of B. Okay. Any doubt here? So what these guys are doing, they are generating their own private key and public key. Similarly, Bob does the same thing. This is a private key and this is the public. Okay. Now what they do is they share their public keys with each other. So capital A is shared with Bob, capital B is shared with Alice. Because it's a public key, you can share it with anyone, right? Now what you are doing with the this public key is once you receive the public key of Bob, you have to use your own private key and take the mod operation. Okay, do the same thing again here. Bob has received A. So what you have to do is A raised to private key of your own mod P. Not alpha, it's A. Any doubt here? So public key of the other user and private key of your own. Public key of other user and private key of your own. Okay. Can someone give me the relation between these two? Just think for a while. No idea? Both are the same. Both of them are same. Okay. So what you are getting here is, let us say, you are getting a key which is a same. Okay, so this key you can use it for AES, DES, or whatever it is. It's a private key which you are not exchanging. Okay, actually you did not send K in this transaction. Okay, but you are generating K at your own end, and directly you are using this K for encryption. So you can use AES on sending X, X, and you can encrypt it with K. Okay, and this guy can decrypt Y with AES inverse, but you'll have to use the same key because AES uses same key at both the ends, right? To produce actual X. Okay, let's say X is sent, I'm sorry, Y is sent by Bob to Alice. Okay, so to do this, you also have to share the key with Alice. But here in this process, you are not sharing actual K, but you are doing all this process. Okay. Now, what is the guarantee that you are getting this as equal or same key? How do you say that it is correct? I have to get a new paper now. Okay. I'll rewrite these things. B raised to A mod p and a raised to b mod b, which we are saying it as equal. Okay. Now, can we replace b here? What is b? How you have calculated b? That is alpha raised to b. Okay. So we'll replace b here. And what is a? It is alpha raised to a. Let us replace that with a raised to b mod p. And you will come to know that both are same. Is it correct? You do BA or AB, doesn't matter. Right. So this will be obviously same. You'll be getting the same value, but you are not sharing actual private key which you are getting after this. You are generating these private keys at your own end. Okay. So this is what the Diffle Helman key exchange program, where you are not sending the private key. If you have any doubts, we can discuss before we see the example. Okay, let us see the example. Let me give you the value of P as 11. Okay, that's it. Only one value is given. Now I have told you that alpha is a primitive root of P. What does it mean? That you have to choose some value, choose alpha, such that it is a primitive root of 11. Okay, so let me pull out the Excel sheet that we have seen already. The value of m is 11. Okay, if you remember, what we have done is we have to consider all the values here for b 1 to 10, and then we have to take the exponential b raised to 1, b raised to 2, b raised to 3, and so on till b raised to 10. That is p minus 1. And we have to take the mod operation. So what could it be? It alpha raised to 1 mod 11, alpha raised to 2 mod 11, alpha raised to 3 mod 11, and so on till alpha raised to 10 mod 10. Okay, all these should have the values 1 to 3 till 10, and they should have unique value that we have seen. If you remember, we have calculated this for all the values, right? And you have to find out the row where all you get all the unique values. I think this is the one. Then another one is, can you just help me finding out the unique row where all the unique values are there?
6.
Yeah, 6. Or this one, maybe this is good. One more.
7.
Anything else? Okay, let it be. So basically what we have to do is let's say we have got the prime number p. Okay, then you have to choose the number bit from these things, these numbers, which are primitive root of 11. Okay, you can either choose the value of alpha as 2 or 6 or 7, anything. Okay, so let us choose alpha as 2. Okay, so from one number, prime number, you are choosing alpha such that alpha is less than p. Okay, now what is the next thing is you have to choose the private keys of Alice and Bob. Okay, so let us choose a small a, Alice, as 8. Any number that you can choose. Okay, from this 1, 2, 3 till p minus 1, and p is 11. So we have the set 1 to 10. So out of this 1 to 10, any number that you can choose, that is a private key of Alice. Okay. Similarly, now once you have chosen private key, you have to calculate a public key. How do you calculate public key? Alpha raised to a mod p. Can you tell me the answer? Yes, anyone? 2 raised to 8 is almost.
The 3.
Okay, this is the capital A is 3. Everyone is getting 3 value. Okay. Let us choose this as 5. So this will be 2 raised to 5 mod 11. What could be this one? (32 mod 11). 33. Is it 2? Is it correct?
Sir, it should be 10, right?
This should be 10.
Yes, sir. Because
2
22.
Okay, sorry, yeah, it should be 10. My mistake. All of you got this problem? So what do you have here is a private key and public key pair. So A for Alice and B for Bob. So what is the value of 8? You have chosen 8 and the capital value is 3. Okay, whereas 5 and 10, private key and public key, right? Now what we have to do is, where is that paper? Yeah. So you have to share the public key with the other user. So what is the public key you are sharing? 3 will be shared with Bob and 10 will be shared with Alice. Okay. So what you are doing with this 10 raised to private key mod p, and you have received 3 here. 3 raised to your private key, that is 5 mod 11. Can you please calculate now? See, I'll have to pull out the calculator in front of you. What is 10 raised to 8 mod 11?
1, sir.
1. And
Yes,
what is
sir.
3 raised to 5 mod 11?
1.
Great. So
Yes, sir.
both of them have generated a private key at their end. Okay, they have not exchanged this private key with each other, but they have generated it. Okay, so now they can use this private key. It's a very simple private key. I'm sorry I chose the very different numbers, but what you can do is yeah. Okay, while choosing these numbers, you can choose your own numbers, okay, so that you can get at least better key here. Okay, just for the example, we have started with the prime number 11. Okay, in practice you don't choose such a small prime number. You choose a very large prime number which is having at least 100 digit or 300 digit. Okay, and when you start with this, okay, we started only with one number and chosen all the alpha. Then you have calculated A, capital A, and all these things. So basically, this is what the process of key exchange, which Diffle Helman have given us. Okay, this is a very effective key exchange program or key exchange technique. If you have any doubts, we can discuss. We might solve few more examples. I can show you. Okay, with few more examples. Sometimes some books are referring that prime number instead of p. I have taken p. Some of them refer it as q. Okay, and then you can do the operations on these things. These are some of the examples. What I can do is we can see these examples maybe next time, and let's see how it goes. Any doubts, guys? I could have gone with the presentation, but it's not. I feel this way is better explanation. Okay, so let me pull out the attendance.